Hey everyone, and welcome to this new section on instructions. Along this section, we will study all the instructions that we can perform in x86 assembly language. In this first lesson, we will study the instruction encoding, that is, the format that an instruction will have, and in future lessons we will see all the instruction lists. The encoding for an instruction in x86 assembly language has the following format. First of all, we'll have 1 or 2 bytes for the opcode. This is the operation code. So this opcode codifies the operation to perform, also the size of the operands, which is the source operand and which is the destination operand. And also finally it codifies if the source operand is an immediate or a register in memory. Then we have here the field mode. This is the addressing mode of the memory operand if we have any. The mode can also codify the register for register operands and can also indicate if there is a displacement in the case that this operand is in memory. We will see examples of this. This field occupies always 1 byte. Then we have SIB is the next field. This is an acronym that references the scale, the index register, and the base register. It always has an occupation of 1 byte. So essentially, if one of the operands is in memory, the SIB codifies this information. So if we delve into memory mode encoding, and we'll look at the SIB, which is a scale, index, and base register, this 1 byte is divided into 2 bits for the scale, 3 bits for the index register, and 3 bits for the base register. Now the possible values for the scale, since we only have 2 bits, we see that it is 0, 1, 2, 3, and this is equivalent to multiplying by 1, 2, 4, or 8. Since we have 2 raised to 0, 2 raised to 1, 2 raised to 2, and finally 2 raised to 3. Keep in mind, since this is represented in binary, for the case 0 we have 0, 0, for the case 1 we have 0, 1, for the case 2 we have 1, 0, and for the case 3 we have 1, 1. After the SIB we have the displacement field that can occupy 1, 2, or 4 bytes. And this displacement is the value that we add or subtract to our memory access location. And finally we have the immediate field that can also occupy 1, 2, or 4 bytes, which is an optional immediate value that we can have in our instructions. A simple example of an instruction to perform is this one here, the move L instruction. If we examine the first thing, and the first value we have here is this $37. So remember, this is an immediate value, okay? Whenever we write the dollar, this is an immediate value. Then the second argument of this instruction is a memory location that we are going to access. So it is an addressing mode. What is this addressing mode? Well, we already studied this before. Remember, this is the syntax and this is the memory location that we access. So if we follow this syntax, the displacement here is minus 40. The base register is the register EBP. The index register, the register ESI, and finally the scale factor is 4. So what we do with this instruction move L is to move this immediate value into this position in our memory. So this first move references the action to move, okay, and this L references the long word data type. This is because we're moving a long word, but essentially what we're doing is to move this value into this position in memory. So suppose this is our memory that we see in here, okay? This is the memory that we have in the x86, okay? Here we have many slots, right? So here, this position is the position we want to put this value in, okay? We want this 37 to be inside this position in memory. And this position is precisely this one. Remember, if we follow the addressing mode lesson that we explained, here the displacement is minus 40, right? The base register is this one, so here the base register is the register EBP, the index register, the register ESI, and finally the scale factor is 4. Once we have all the components from the past lesson and the previous lesson, we know that this is the position in memory that we are going to access. Hence, this position in memory is going to be RB, which is the base register. So here we have EBP, right? Then we add the index register multiplied with the scale factor, in this case multiplied with 4. And finally, we add the displacement. So since it is negative, we here subtract minus 40, like this. And this is the position in memory that we want to put this value in. Okay, and suppose that this position in here is this one. Okay, this is the position in memory. So what we do with this instruction is to move this value inside this position, right? So at the end, we will have here this value and this immediate 37, like this. Very well, this was just and only a simple example. We will study the rest of the instructions and all of the instructions in the following lessons.